here we are back again with exponents. We have already gone over adding and subtracting and combining like terms. And when we combine, nothing happens to those exponents. When we multiply, my exponents add. And now, what happens when we raise a monomial to a power? What happens with my exponents then? We do something and it's called the power rule. And you need to know this rule. So anytime you have an exponent raised to a power, you are going to multiply. My exponent, or my variable is x, and we're going to multiply up here, a times b. And we'll talk about why in these examples. So here I know if I follow the power rule, it's 2 times 5, because here's my exponent, to the power is 5, so I get x to the 10th. But why? Well, let's think about this. If you have x squared written 5 times, that's what this means. X squared times x squared times x squared times x squared times x squared. Now, because of the product rule, I know that I can add my exponents. 2, 4, 6, 8, 10, and I get x to the 10th power. And if I still didn't understand that, I could even break it down further, because x squared is x times 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 x. So if we broke it down like a factor tree and listed all my factors, this is what it would come down to. And it would, no matter which way we looked at it, it would be x to the 10th power. But we don't want to work with that when we have something like, raised to the 50th power. It would be too long to write that in expanded form. So that's why we have that rule. Anytime you have an exponent raised to a power, we multiply. So if we look over here, I have m to the 28th, n to the 16th. An exponent raised to a power means multiply. Over here, remember, it is understood for it to be c to the first power. So c to the third power, d to the 6th. And again, if you get lost at the beginning because this is new, you can write it in expanded form. Because if we looked at this, what does it really mean? It means cd squared times cd squared times cd squared. And how many c's do you have? 3. And how many d's do you have? 6. So no matter how you do it, you're still going to arrive at the right answer, but you can always do expanded form. So again, when we have these examples with now we have a coefficient, you've been doing this part forever. You know 5 squared. There's no new instruction there. You have to do whatever your coefficient is telling you to do. So it's saying 5 squared is 25, and now I get x to the 14th. Number 5, 2 to the 5th power. That's 2 times 2 times 2 times 2 times 2. Don't tell me it's 10. It's not. 2 to the 5th power is 4 times 4, which is 16. 16 times 2 is 32, and x to the 10th, y to the 5th. So don't forget that coefficient, that he just does what he's supposed to do. Number 6, negative 2 squared. A negative 2 times a negative 2 is a positive 4, p to the 8th, q to the 12th, because I'm multiplying these exponents. Number 7, I get negative 4 to the 4th power. That's a negative 4 times a negative 4, which is 16, and then a negative 4 times a negative 4, which is a positive 16. And 16 squared is going to give me 256, and now I get c to the 12th, d to the 16th. Number 8, negative 3 cubed. You got to remember your rules for those negatives. So a negative 3 times negative 3 is a positive 9, times negative 3 is a negative 27, x to the 6th. 1/2 cubed. That means 1/2 times 1/2 times 1/2. So when I multiply my numerators, I get 1. When I multiply my denominators, I get 8. So it's 1/8, a to the 9th, b to the 12th, c to the 15th. Okay? All right. Let's do some mixed practice together, and we're going to do all of these because the more practice we have, the better. So here, I'm going to do order of operations. So you have power to a power. So I'm going to do x to the 9th, y to the 9th. That's this part simplified, times xy squared. And remember here, now I'm just multiplying. So what do my exponents do? We add. So I have x to the 10th, y to the 11th. Let's slow that down a second. This is a power rule. So I multiply 3 times 3 to give me x to the 9th. I multiply 3 times 3 to give me y to the 9th. Right? That's this first part. And when I multiply it times xy squared, now we're just multiplying exponents, which means my exponents add. And I get x to the 10th because it's understood to be 1 and y to the 11th. All right, let's take a look over here at number 11. I get a cubed times, when I simplify this negative 1 to the 4th power, because that coefficient's negative 1, negative 1 to the 4th power is a positive 1. Because negative times negative is a positive, negative times negative is a positive, positive times positive is positive. So I get positive 1, a to the 8th, b to the 4th. And now, when I multiply these guys, my exponents add. So I get a to the 11th, b to the 4th. So let's break number 12 down. So I'm going to do this rule first, the power rule. Negative 2 squared is 4, a squared, b to the 4th, times 3 squared is 9, and then multiply 2 times 2 to give me a to the 4th, b squared. Now I'm just simply multiplying these guys, and I get 36. I'm going to add my exponents to get a to the 6th, b to the 6th. So that is my final answer. Number 13, 6 cubed is 36 times 6. 36 times 6 is 216, and I get a to the 6th, b to the 3rd. Times 1/3 squared is 1/9, and I get a squared, b squared, c squared. Now remember, I can cross multiply. 2, 16, and 9 cancel out to give me 24, and then I can add my exponents. A to the 8th, b to the 5th, c squared. Okay? I'm going to erase that so we can see the next part. So, 2 cubed is 8, a to the 6th. When I multiply these guys out, I get 3a to the 6th. And look, can I add those? Yeah, because they're the same like terms. So I get 11. My exponents do not change. 11a to the 6th. Combining like terms, don't change those exponents. All right, let's look over here. I get 3 to the 4th power, which is really 3 times 3 times 3 times 3. So that gives me 81, x to the 12th, y to the 4th. Minus, I've got to do this in here, 7 squared is 49, x to the 10th, y squared, times x squared, y squared. So notice I had to do order of operations. I did this power first, then I did this power. What comes next? And please excuse my dear Aunt Sally. I did parentheses, I did exponents, so now I'm going to multiply. So I've got to multiply these guys right here. So I get negative 49, x to the 12th, y to the 4th. Well, then I look over here at this guy. Are these the same? Yes, these are the same. I can combine them because x to the 12th, y to the 4th is the same. So when I combine them, I get 32, x to the 12th, y to the 4th, realizing my exponents don't change. Okay? All right, so a lot of rules, but if you keep them, they're just easy. It's a rule, you just follow it. All right. So let's look at the geometric applications. So when we have perimeter and area, you know how to find the perimeter of something. You add up all the sides, right? So if this is a rectangle and this length is 12x, this length is 12x. If this width is 5x squared, this is 5x squared. So if I ask you perimeter, perimeter is you adding them all up. You can't add x squared and x, unlike terms. So we combine like terms. So I get 12x and 12x is 24x. 5x squared and 5x squared is 10x squared. Notice your exponent doesn't change. Now if I have area, area is base times height. So my coefficient does what he's told. 12 times 5 is 60. And then x times x squared is x to the 3rd. So that's my area. My perimeter here, when I add up on my sides, these guys are alike and this guy is alike. So together, that's 14a squared b plus 3ab. When I add them all up, that's the simplified answer. area of a triangle is 1/2 base times height. So I'm going to do 1/2, my base is 3ab, times my height, which is 4a squared b. So I can get 12a to the third b squared times 1/2, and that gives me 6. Half of 12 is 6, a cubed b squared. So that's my area for the triangle. Let's take a look at number 18. We're going to, now normally in math we do not assume, but we're going to assume right here, just because I know this is an equilateral. 20am n to the 5th, so this side is 20m cubed n to the 5th, and this side is 20m cubed n to the 5th. So the perimeter, if I added them all up, all like terms, so I get 2, 4, 60 m to the third n to the 5th. And my area is base times height, so 20 times 4 is 80, but then I divide it by 2, which is 40, and my exponents multiply. So I get m to the 4th, n to the 10th. So really, if my formula is 1/2 base times height, notice it's 20m cubed n to the 5th times 4m n to the 5th, all divided by 2. It's base times height divided by 2. So that's why I could do that quickly. Because 20 times 4 is 80, divided by 2 is 40, and then my exponents just add here. All right, to find the area of a trapezoid, first we got to remember what it is. So the area is base 1 plus base 2. I add these bases, I multiply by my height, and I divide by 2. That's what's going on here. So when I add my bases, are they like terms? They are. So that gives me 11x squared y. I'm going to multiply it by my height, which is 2xy, and then I divide by 2 is my final. So when I multiply 11 times 2, I get 22x to the third y squared divided by 2. 22 and 2 cancel out, and that gives me 11x cubed y squared. So pause that and slow down, but remember the trapezoid. Add up your bases, multiply by your height, and divide by 2. Okay? That's what we get there. All right, for a circle, to find the area of a circle, area is pi times radius squared. So I want you to keep this in terms of pi. That means I want pi to remain in your answer because pi is one of those irrational, never-ending numbers, so it's never going to be perfect. So I want you to do pi times my radius is 3xy cubed, and I have to square it because it's radius squared. So all that's changing is my radius, which is 3xy cubed, and so now I'm going to evaluate this. Order of operations says I must do this first, and I get 9x squared y to the 6th because it's an exponent raised to a power, so I do the power rule, which is multiplying, and then you just multiply it by pi. So the way that's going to look is this pi is going to come directly after your coefficient. So it's really 9 pi x squared y to the 6th. And that is my final answer. Okay, so that's just another rule. If this didn't make sense, that means you need more practice. So come on in and see me. Good luck.